Take the derivative of f of x equals x minus 5 over 2x plus 1. This, boys and girls, is the quotient rule. Now, different teachers handle the quotient rules different ways. You may have heard your teacher mention high D low and low D high. It's a rhyme that helps you remember things. Or maybe they use F's and G's. This is what I do. I view the numerator as u and the denominator as v. So d dx of u over v is going to look like this. Now again, whatever your teacher does, whatever letters your teacher uses, it's all going to be the same thing in the end. I do u prime v minus v prime u all over v squared. All right, that is going to be the quotient rule. So now that I know what u is and now that I know what v is, I like to just kind of go off to the side and take the derivative of each one. So u prime is going to be the derivative of the numerator. So the derivative of x is 1, the derivative of negative 5 is nothing, so u prime is just 1, easy peasy. V prime is going to be the derivative of the denominator. The derivative of 2x is 2, the derivative of 1 is nothing, so v prime is 2, easy peasy again. Now v squared is going to be what the denominator is when all is said and done, and that is going to be 2x plus 1 squared. Now, I am not going to FOIL this out. I'm not going to do a perfect square trinomial because every now and then when you throw everything on up here, things simplify and you might be able to cancel stuff out. Does that happen all the time? No. Does that happen sometimes? Yes. So I'm not going to FOIL this out, not yet. So let's set it up. F prime x is going to equal u prime is 1, times v is 2x plus 1, minus v prime, which is 2, u, which is x minus 5, all over v squared, which I'm keeping as 2x plus 1 squared. Okay? Let's distribute that 1, which means nothing happens. Let's distribute negative 2, not 2, negative 2, and we get minus 2x, how nice, plus 10. And that's going to be all over 2x plus 1 squared. You cancel out. 1 plus 10 is 11. So f prime of x is going to equal 11 over 2x plus 1 squared. And I'm going to leave it like that. If you have a teacher or a professor that says, no, you must FOIL it out, great. 4x squared plus 4x plus 1. Here, yippee. I did it for you. But yeah, that's what you would get. Okay? So quotient rule is very important. You're going to see it a lot. This is how I do it. This is how I do. Like and subscribe. Find the derivative of f of t equals t plus 1 over the square root of t. Boys and girls, this is the quotient rule. The quotient rule says if you take the numerator and call it u and the denominator and call it v, then the derivative of the numerator over the denominator is going to be the numerator prime times the denominator minus the denominator prime times the numerator all over the denominator squared. All right, so I like to go off to the side, and I like to say what each thing is, okay? So u prime is going to be t plus 1, well, the derivative of t, which is 1, and then plus 1 is nothing, so u prime is just 1. Okay, I would like to envision v, and I'll just write it down because why not, v as root t, which is actually t to the 1/2. I don't know why I put that root t there. T to the 1/2. So the derivative of t to the 1/2 now uses power rule. Bring down the 1/2, okay, t to the 1/2 minus 1, which is negative 1/2. Okay, drop down that t to the negative 1/2 to the denominator, like that, and turn it back into its square root version, and you're good to go. V squared is going to be the square root of t squared, which is just t. That's nice. So let's put it all together. Okay? F prime of t is going to be u prime v. So u prime was 1. V was square root of t minus v prime, which is 1 over 2 times the square root of t, times u, which was t plus 1. All over v squared, which is t. So this is not going to look pretty at all. That's all right. V prime of t equals 1 times the square root of t is the square root of t, minus, let's put t plus 1 in the numerator, so t plus 1 over 2 root t over t. And I think I'm going to leave it like that because who cares? I mean, there's nothing wrong with having, fractions everywhere. Some teachers might not be happy with this, but I'm going to leave it like that. I mean, I guess what you could do is multiply the top and the bottom by 1 over t, and that would help, and then you would end up combining fractions. But I don't know if that's necessary. I'm just going to leave it like that because it's calculus and I'm allowed to. So there you have it. If y equals sine x over regular x, then dy dx equals, well, this is going to use, kids, the quotient rule. The quotient rule says if you take the derivative of something in the form u over v, and sine x would be u and x would be v, so u over v, you would do u prime v minus v prime u all over v squared. So what I like to do is I like to go off to the side. U is sine x, v is x, so u prime would be the derivative of sine x, which is cos x, like that. V prime is going to be the derivative of x, which is just 1, and v squared is going to be x squared, which is x squared. Nothing crazy, nothing fancy. There you have it. So dy dx would be me putting this all together. Dy dx is going to be u prime v, which is cos x is my u prime, v, which is regular x, minus v prime u. V prime is 1, u is sine x, all over x squared because it's v squared. Cleaning this up a little bit, dy dx is going to be x cosine x minus sine x over x squared. And there's not much you could do with that. I mean, there's no more that you can simplify. There probably is some clever technique, but that's it. I mean, we did quotient rule. It's a pretty quick problem, pretty basic problem, nothing wacky here. We end up with that as our answer, so there you have it. Determine the x values, if any, at which the function has a horizontal tangent line. Now, a horizontal tangent line means slope is going to equal 0. So what I have to do is I have to find the slope of the tangent line, which means derivative, and then set it equal to 0. Well, this, boys and girls, is quotient rule. So I'll label u and I'll label v, and the quotient rule says that if I take the derivative of u over v, I get u prime v minus v prime u all over v squared. Okay, so let's do that. Let's find out what u prime is. Okay, so if u is 4x cubed, u prime is going to be 12x squared because of power rule. And if I have negative 10x squared, then that's going to become negative 20x because of power rule once again. V prime is going to be the derivative of 2x, which is 2 because of power rule. And then v squared is going to be 2x squared, which is 4x squared because of multiplying things. Now let's set this all up. Okay, v prime of x is going to equal u prime v, so u prime was 12x squared minus 20x times v, which is times 2x, minus v prime. V prime was just regular old 2, times u, which was 4x to the third minus 10x squared. And that's going to be all over 4x squared. Okay, so let's set this equal to 0, because that's the next step. Let's distribute that. U become 24x to the third minus 40x squared. Let's distribute negative 2 minus 8x cubed plus, that was a close one, plus 20x squared all over 4x squared. Now, whenever you have 0 equals blah, blah, blah over stuff, that bottom stuff doesn't matter. Get rid of it. Because you would just multiply both sides by 4x squared and then it's gone. So 0 is going to equal, let's combine like terms. Okay. So 24x cubed minus 8x cubed is going to be 16x cubed. Positive 40x squared plus 20x squared is going to be minus 20x squared. Okay. Let's factor out a 4x squared. And so that becomes 0 equals 4x squared. And then we're left with 4x minus 5. Okay, so over here in purple, where I have a little bit more space, we can do the zero product property and set 4x squared equal to 0, divide both sides by 4, which keeps it at 0, take the square root of both sides, which is going to be plus or negative square root of 0, and x is going to equal plus or negative 0, which is just 0. So we got a double root going on there. Okay, easy peasy lemon squeezy. Then over here, and we'll use green because we haven't done that yet, I have 4x minus 5 equals 0. Add 5, so 4x equals 5. Divide by 4, and x equals 5 over 4. So my two x values that give me horizontal tangent lines are going to be x equals 0 and 5 over 4. And it was the quotient rule that gave us that. Thank you, quotient rule. Thank you so much. What is the derivative of f of x equals ln of x over sine x with respect to x? This, boys and girls, is the quotient rule. So I'll label the numerator u and the denominator v. And I'll remind myself that the quotient rule says that the derivative of u over v is u prime v minus v prime u all over v squared. So let's find each one. All right. U prime is going to be the derivative of ln of x, which is 1 over x. V prime is going to be the derivative of sine x, which is cos x. And v squared is going to be sine squared, so sine squared x. Okay, let's build it. Let's build it. d dx of u over v, so I'm going to call it f prime of x. Don't know why I did that. Let's call it f prime of x is going to equal u prime v, so 1 over x times v, which is sine x, minus v prime, which is cos x, times regular u, which is ln of x, all over v squared, which is sine squared x. So f prime of x is going to equal, let's do sine x over x minus cos x ln of x over all over sine squared x. You know, I look at this and I'm like, I don't see any point in continuing and trying to make this into one big fraction and then multiplying the top and the bottom by 1 over sine squared x. So we're going to go with this. I think that's fine. You know, these problems, they just get sloppy and they don't look much prettier once you keep going. So I'm going to keep it like that. That's my guy. And that's my answer. Quotient rule.